Okay, students, now we come to the next topic of second half of the unit 2, the propeller shaft. Let us look at the functions and requirements of the propeller shaft. Propeller shaft or drive shaft is a driving shaft that connects the transmission to the differential. Transmission means the output shaft coming from the gearbox. This is the propeller shaft. This is the transmission shaft or the shaft which is coming out, the output of the gearbox. This is the propeller shaft. It has mainly three parts. The first is the shaft itself. This is the shaft. This is another view of shaft. This is shaft. This is the shaft. Usually made of tubular cross section, mostly. It may be solid also, like this is a solid one. Tubular cross section to withstand torsional loads. Tubular section withstands torsional loads. Has to be well balanced. It also has to be balanced. The way we balance our wheels, wheel balancing, this also has to be balanced to avoid whirling at high speeds. Speed there's one reduction at the gearbox after that, but still the speed is still high. We know the RPM of the engine can vary anything between 3000 to 5000 or even 6000 modern cars, revolutions per minute. Of course, the speed comes down when it comes to the propeller shaft because the gearbox has a certain amount of reduction. And at that speed, high speed, whirling. What is whirling? This is whirling. ये whirling होती है. To avoid whirling at high speeds. It is made of steel, aluminium or a composite material. Second part is the universal joints or UJ. Now, this is the universal joint. We'll study more in detail, just showing you on the figure. Ahead we will understand what is the function of universal joint. There may be one or there may be two, depending upon the type of differential which is going at the rear. Depending upon the type of the rear axle. Depends upon the type of rear axle. This is generally, the rear axle is generally lower than the output shaft of the gearbox. So this is generally like this in actual case, like this. Third is the slip joint. This is a slip joint to adjust the length of the propeller shaft. This is sliding joint or slip joint because the propeller shaft length will change. Let's say when the back axle goes over a speed breaker, goes in a gadda, this length will change, and therefore there must be a provision to be able to slide the propeller shaft so that there are no jerks or it doesn't break. Slip joints also, both these we will study ahead. What is the function and how is construction. Now first, let us come to the universal joint. As I mentioned, this is a universal joint, this is a universal joint. It is used where two shafts are connected at an angle to the transmission torque. It is used when it's connected at an angle. Look at the angle. This is one shaft, this is another shaft, this is an angle is being made, and this is called a Hooke's joint, it's universal joint, a type of universal joint when it is at an angle. Now, as I mentioned earlier, this is the back axle is generally lower down at an angle. When it is there, we use. So if there's an angle, you will use two universal joints. If there's no angle, then one is sufficient. One universal joint is sufficient. But it's never that case to the transmission torque. One universal joint is used to connect the transmission main shaft, that is the transmission main shaft, the gearbox output shaft, and the propeller shaft. This is in between the transmission shaft, the output gearbox, and the propeller shaft. And the other one is used to connect the propeller shaft to the differential pinion shaft. The pinion shaft or the shaft which is going into the differential, that big gola which you see behind trucks, that is the differential. तो उसके अंदर जो input shaft है to the differential, that is called the differential pinion shaft. So it is a connection between the output shaft of gearbox and the input shaft of the differential. So between them you have propeller shaft is there, you have one universal joint, another universal joint. Thus, the connection between the three shafts are flexible at an angle with each other. Flexible as well as an angle with each other. Here's another view. This is the transmission shaft, this is the input shaft, they're at an angle, so it connects. These are the two universal joints. Thus, the connection between those are flexible and at an angle with each other. The universal joints permit torque transfer not only at an angle, but also when the angle is changing constantly. Angle is changing constantly because of the ups and downs on the road. There's speed breakers, gadda, even on the GT road which is smooth, there is always some variation in the road, and you will never find it perfectly still. There will be slight movement, and this is where the universal joint comes into play. Okay? Construction. Let us look at the construction of the universal joint. It consists of two Y-shaped yokes. Two Y-shaped yokes. Let's say this is one, this is the other. Two Y-shaped. This is one shaft coming with a Y. This is Y here. This is another one. This is another shaft. Y-shaped yokes. In between is something else which you just learned. Two Y-shaped yokes. Y-shaped yokes. One on the driving shaft and the other on the driving shaft, other on the driven shaft. And a cross piece in between this is a cross piece. Here also it's shown. This is a bigger exploded view, and a cross piece. Here also it's shown. Here also it's shown. Here also it's shown. This is the best view, and a cross piece called the spider. So this is a spider. This is the spider, actual spider. The four arms of the spider. 1, 2, 3, 4. 1, 2, 3. This is the actual view. This is a diagrammatic view. This is the actual view of an actual part. You may have seen, this is a universal joint called Hooke's joint. You must have seen on the roadside, some workshop. You must have a look. 4 arms of the spider are known as trunnions. The driving and the driven shaft are at an angle to each other. This becomes the driving shaft, this becomes the driven shaft. Here it becomes the driving shaft, this becomes the driven. So, are at an angle to each other. The bearings in the yokes, the bearings in these yokes permit the yokes to swing around on trunnions on each revolution. If you see the construction, here you see their bearings. This probably needle bearings would be there. Retaining ring, bearing clip inside their needle cup, needle bearings, plastic washer, and this is flat plastic washer, a seal comes into this. So this is the trunnion, 4 arms, and their needle bearings in each, and this rotates. This joint, this is the driving shaft, this is the driven shaft, and the whole assembly rotates. Because of these bearings, you can have an angle on each revolution. Slip or flexible joint, I briefly mentioned. Sliding joint, slip joint, flexible. Depending upon the type of drive, one slip joint may be there in the shaft. This is to adjust the length of the shaft due to road variations, speed breaker, pedals, anything may come up. The length of the propeller shaft will change. So if it moves in, it should be able to move. So this is called the sliding joint, which allows the propeller shaft to move this way. This serves to adjust the length of propeller shaft when demanded by the rear axle movements. The rear axle up and down due to the reasons I mentioned, and therefore this length of this will keep changing, and to adjust this length we have the sliding joint. Slip or flexible ring joint. Flexible ring joint. Depending on the type of drive, one slip joint may be there in a shaft. This serves to adjust the length of the propeller shaft when demanded by this VF curve. Now we come to the constant velocity joint. When there are two universal joints, this becomes a constant velocity joint. The angle, however, should be the same, which is generally not there, maybe variation of a few degrees, 1, 2, 3 degrees. But when you use two universal joints, it becomes a constant velocity joint, because the velocity of this, we want the velocity of this to be the same as the velocity of this. We are just transmitting torque. We don't want a change in velocity. So this. To achieve uniform driven shaft speeds, two universal joints are used, known as CV joint, constant velocity joint. Two UJs become constant velocity joint. The intermediate shaft, in this case it's the propeller shaft, this is an illustration. The intermediate shaft makes equal angle with the first and third shafts. Angle theta is shown clearly here. First and third shaft. This is first, second, third shaft. This is just to explain, very simple, so that you understand. Variation caused by one joint, this is the variation caused by one joint, is cancelled out by the second joint. Because the angle is same, it cancels out. This variation is cancelled by this variation. But remember, this is valid only if both the angles are equal. Generally, it's not the case. There will be slight variation, but it serves the purpose. These angles, we take it theoretically, are the same. Then we come to the rubber bushed flexible joints. Rubber bush, this is a solid tube. This is used on solid tube. On top of the solid tube propeller shaft, there is another tube, and there's a rubber element inside too, so that there is no noise, and the operation of the propeller shaft this operation, sliding joint, is smooth without any noise. So you can see this rubber element inside between the two concentric tubes. This is solid. This is of course hollow. This is mounted on top of this. So you get a slip joint also, and you get the rubber element which provides the noiseless and smooth operation. This universal joint incorporates rubber element between two sliding tubes to make the relative movement smooth and noiseless. It is used in propeller shaft with solid tube. This lower one is solid tube. This is hollow. This is mounted through a rubber element so that there is no noise. This is the actual figure. I think I've explained all these. This is the CV joint. Now next. That finishes the propeller shaft. Now the next topic is the final drive and differential. This is a very interesting topic. Final drive and differential. Now we talked about initially the differential pinion shaft. The differential pinion shaft, after the second universal joint, this goes into the differential. Now this is a differential shown. This is that shaft. This shaft is nothing but this shaft. Pinion shaft, which is coming into the differential. and it has got a bevel pinion here and a crown wheel. This bevel pinion and crown wheel is the final drive. This is the whole axle. So this is the wheel. You see, final drive is this part. It's a reduction, causes a reduction, and that's why the size of these two wheels is different. This is bigger, this is smaller. We'll see why. So on this shaft is fitted this pinion. This shaft, there's a pinion, and this goes into the differential. So final drive, differential we'll see in the next lecture. Let us see final drive. Final drive is the last stage in transferring power from the engine to the road wheels. So the road wheels, this is the last stage. First stage was gearbox. There was a reduction there. You know, there are 4 gears, reverse, that's a manual, and the reduction is that much. First gear means what? That reduction, the gear ratio is the reduction. It's maximum in first gear and least in fourth gear, but the reduction is there. And that reduction in the gearbox is variable. First gear, second gear, third gear, fourth gear. Here the reduction is fixed, because you cannot change the size of the crown wheel. This is inside. Now what is this differential? This is nothing that so many times I mentioned. If you're traveling behind a truck on the GT road or big road, that big gola between the two wheels encases the final drive and the differential. The differential parts are not shown here. That we will study in the next lecture. There are various other gears and here, there. But we are only concerned with this final drive in today's lecture. It provides a fixed reduction because the size is the same, the reduction is phased. And what will be the reduction? The number of teeth on this divided to the number of teeth on the crown wheel. Number of teeth on the pinion wheel to the number of teeth on the crown wheel, that becomes the reduction, which is fixed between the drive shaft and the driven axles. Between the drive shaft and the axles. This is shaft and the driving axle. This is the driving axle, this is the wheel. And then it brings down the speed of the propeller shaft to that of the wheels. After the first reduction in the gearbox, it further brings down the speed to that of the wheels. Speed of engine is 3000 to 5000, 6000, 7000 RPM. You can't start. If there was no gearbox and no final drive, you suddenly transfer at that RPM to the wheels. It will take off like an aircraft. You will not be able to control the vehicle will fly, virtually almost. It brings down the speed, you have to bring down the speed, and that is one reason why we put the gear in the first gear. We start in first gear. First gear, maximum reduction, this reduction is fixed, but we want the maximum reduction so that the speed of this driving shaft is the release so that the wheels can start slowly. Vehicle is at rest, we want the wheels to start slowly. And then as you pick up speed, first gear to second gear reduction is less than accordingly third and fourth gear. Try to understand. Then it turns the drive of the propeller shaft through right angles to drive the wheels. It drives the final drive through right angles. This is the right angle to the one. This is only one wheel shown, the other is this side, second wheel. So it's a right angle 90 degrees turn to drive the wheels. Next point, the crown wheel is larger, as I mentioned, than the bevel pinion and this bevel pinion. Therefore, the speed of the crown wheel is lower than speed of the bevel pinion. And this is the amount of reduction. The speed, how much less it will be? Depending on number of teeth on this to number of teeth on this. This will move very slowly. This will move faster. The reduction provided is about 4:1 in cars for final drive. For final drive is 4:1. That means there are 4 times more number of teeth on this compared to the bevel pinion in cars, and about 10:1 in heavier vehicles. Heavier vehicles, that means this heavy vehicle, the crown wheel will be very big, much bigger than one shown. And therefore, these big trucks, you have big differential, big round thing at the back, differential. To accommodate this, it's big because this crown wheel has to be accommodated inside. There's oil also in this. And 10:1 in heavier vehicles. For lesser reduction of about 7:1, till 7:1, single reduction. If it's more than 7:1, you'll have to have a two-stage reduction. That is not in the scope of your syllabus, that those who are interested can see. So, this is final drive. The next lecture, very interesting, the differential. We'll study the differential. Differential is nothing but inside this. This is the differential. And what is the purpose of differential? What does it do? That all you will study in the next lecture. Thank you.